Hello everybody and welcome yet again to another lesson for your CompTIA A+ 1201 exam, where we're going to be going through all of these basic common networking hardware devices. I'm going to tell you all about all of these devices, everything you're going to need to know about these for your exam. I'm going to tell you what they'll probably ask you on your exam, and then I'm going to give you some practice questions that can give you an idea whether or not you are ready for the real thing. So I'm going to tell you what you need to know, what kind of questions they might ask you, and finally I'm going to give you some practice questions that you can use. So that being said, I'm going to put my glasses on so I can see, and we're going to go ahead and get straight into it, starting off at routers. All right, let's have a look at routers. Now, routers, we've had a little look at them already throughout this learning process, this learning journey that we have been on together. A router is known as the gateway, right? A router connects your local area network to the outside internet. It is the thing that allows your data to travel from inside your network to outside your network. So it looks like this, right? You've probably seen one around your home. We all have a router in a house. It's what you need to use in order to set up internet. Something like all of these. I just did a quick Google image search. But essentially, at the end of the day, a router looks like this, could look like any one of these, but it is what connects our internal network to the outside external network. And there's a couple of key things that categorize it. The first thing is the idea of a network gateway. So throughout your exam, whenever anything is referred to as a gateway, they're essentially referring to the router. So routers serve as the bridge between your local area network, or your LAN, we should be familiar with that term by now, and the wider internet, or the WAN, wide area network, enabling communication between different networks. We'll get specifically into how they do that in an exam objective coming up soon, but just know your router, right, kind of like this. You've got your wide area network out here. That's everything outside. And then you've got your home, which has all your internal devices, right? The router is what allows the two to talk to each other. Without the router, you cannot connect to the outside world, all right? Your router does a whole range of cool stuff. Like you've got your smartphone, you've got your desktop computer, you've got your television in the inside of your home, and your router essentially connects all of these. It provides them all with a private IP address, and it says, hey guys, look, if you ever want to talk to the outside internet, you just go through me and I'll transmit all your data out there, and I'll bring data in, and I'll make sure you get the data that's meant for you. That's what the router does. It's a really cool guy, right? Router connects your internal internet to the external WAN, or to the outside world. Long story short, what you need to know is they do work with IP addressing. So they work with IP addresses, right? It's not like a switch, which works based off MAC addresses. It works off of IP addresses. So based on what IP address is within that data packet, for the IP that it's meant for, it will look at how to get to that IP and how to best send it there. And it uses something called a routing table to do that. So within every router, you'll find a routing table. And it's something that looks like this. You don't need to be able to read or interpret this. You just need to know that a router will use IP addresses to forward data, and it connects your local area network to the wide area network. That's honestly, truly, I'm telling you, that's what you need to know. You don't need to be able to read a routing table until you get to Network Plus, but just understand it works off of IP addresses, right? So this routing table, it is essentially saying, okay, if I want to get to one IP address, I need to have a look at my table and send it along this path. Long story short, that's what it's saying. You don't need to be able to interpret that. All right. That's it. Look, long story short, that's it. That's what a router is. That's what you need to know. Next thing is a switch, or switches. We have a couple of different types of switches that we need to know about, but let's just take a look, right? We've covered the idea of switches already through this exam. A switch basically works off of MAC addresses. So you have a switch here, and you have a lot of Ethernet cables plugged in. Now, when you plug your Ethernet cable in, right, you have your device plugged into Ethernet, and then you plug the other end of your Ethernet into this switch here, it will see the MAC address that is connected to that cable. So it knows the MAC address connected to all of these cables. And based off of your MAC address, remember we've talked about MAC addresses before, your network interface card, or your NIC, the little card that goes in your laptop or into your desktop, gives your device that unique MAC address. Based off of that MAC address, the switch will forward that data, all right? Long story short, that's really how it works. That's what a switch is. A switch forwards data based off of a MAC address. So you can have a wide variety of devices plugged into each one of these slots, and based off of the MAC addresses, this will forward that data. Now, we need to know some more things about it, right? The main thing is it uses MAC addresses to forward data. You do need to know about that, but there are two types of switches you need to know, right? Again, in case it wasn't clear though, guys, the switch does forward data in your LAN. So remember, the router needs to send your data from inside your network to outside. So your switch, you would connect all of your devices. Like if you had a house, right, and you had like a laptop up here and a laptop up here, maybe another device up here, another device up here, and you had your switch over here. Generally, you wouldn't have a switch in a house, but just for example's sake, this might be a business office or whatever. You would connect all of these devices to your switch. La 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 la, connecting. And then you would also have your router over here, and you'd connect that to your switch. So your switch would have access to the MAC addresses of all of these devices. It would also have access to the MAC address of the router. So it would be able to then forward data from this device to your router based on the MAC address, and from there your router would take it out into the wide area network, into the internet. Just know the switch operates on MAC addresses, the router operates on IP addresses, and the router is the one that sends it out into the world. Right? That's pretty much what you need to know. Other than that, you need to know about two types of switches. Okay, you've got one type of switch, sorry, which is a managed switch. We do need to know what this is. Now, a managed switch essentially allows us to do a lot of really cool things that require us to manage the switch. It allows us to connect to the switch and manage it. It allows us to connect to the switch and give it very specific instructions on how we want it to function. So we can create a VLAN, or a virtual local area network. We talked about what that was before in one of the last learning objectives, remember? But just as a quick reminder, a virtual local area network is when you have all these physical connections on a switch. It's all in the same switch, but you tell the switch, actually, just pretend these are 3 separate networks, or pretend these are 2 separate networks. So just like we have these 3 boxes separating them, right? This one might be for finance, this one might be for security, and this one might be for sales, for example. You could create separate virtual local area networks for each of those. You can only do that on a managed switch. The managed switch is what allows you to have those capabilities. You can also use SNMP, or Simple Network Management Protocol. That's one of the protocols you'll need to know for your ports and protocols as well, which actually enables remote monitoring and management of the switch, allowing administrators to track network performance and troubleshoot issues. So that allows SNMP on a managed switch. You can also choose what traffic you want to prioritize on a managed switch. You can also set up port mirroring, which enables monitoring of network traffic by duplicating data from one port to another for analysis on a managed switch. And you can do other advanced configuration options. There's a whole wide variety of things you can do on a managed switch. This is why this guy looks so happy, because he really forked out his money to get a managed switch so he could set up his switch exactly how he wanted it to. Managed switch allows you to do specific configurations. That's pretty much what you need to know. That's in contrast to the other type of switch you need to know for your exam, which is an unmanaged switch, right? You can not do all of that really specific stuff that we talked about with the managed switch. With an unmanaged switch, you have basic functionality, all right? So basic switching capabilities without advanced features like VLANs or Simple Network Management Protocol, right? You don't need any real configuration. It's pretty much plug and play. You don't need to configure it. It's generally less expensive. It's cheaper. But if you did want that advanced capability to manage and set up all of that stuff, that's probably not going to be the one you wanted to go with, which is why this guy over here looks sad, because he really can't do any specific high-tech stuff with his switch. He got an unmanaged switch. With an unmanaged switch, you do not have all of those advanced capabilities that we were just talking about, okay? That's really what you need to know about for the most part. Unmanaged switch does not have those advanced capabilities. The next thing we need to know about is access points. So access points are a key thing we need to know about for your exam. Long story short, you've probably seen them around if you work in a business setting at all, anywhere really. You'll see things like these on the wall, right? Might look like that, might look like this, might be a little thing over here. Essentially, it's a point in the wall or on the roof, right? Could look like this as well, that allows you to wirelessly connect to the internet from a wide variety of locations. So it extends your internet coverage, all right? If you have a router, but the router doesn't reach the whole building, if you're in a big business area, you might connect multiple access points to that router so you can extend the internet coverage. So, long story short, we have our key points here. Wireless connectivity, access points allow you to connect wirelessly with Wi-Fi, and you can extend that Wi-Fi coverage too. So that comes into network extension. You can extend how far your network can go. If you can't reach the other end of your hallway, you might want to put an access point at the other end of that hallway. They forward data based off of MAC addresses. Again, they don't use IP addresses. They do use MAC addresses, which come from what? Your network interface card, or your NIC. That's right. I know you knew that one. I know you said it out loud. I feel a little bit like Dora the Explorer right now. And the idea of network bridging is just they act as a bridge between the wired network and the wireless. So they allow you to connect to a wired network wirelessly, right? That's essentially what that means. Access points give you wireless access to a wired network. They give you Wi-Fi, and they can extend your network coverage, how far it is covered, right? The location. So that's pretty much what it means. Now, you probably won't have an access point in a home because generally the router acts as its own access point, which is why you generally only really see them in enterprise settings where you need to really extend that wireless access coverage throughout a pretty dense area, right? So your business, your school, any sort of businessy type setting is probably going to have access points. Your home, generally your router actually acts as the access point itself, okay? So that is an access point. Just know that it helps you connect wirelessly to the internet. You can extend your coverage with an access point, and you will be sweet, ready to pass the exam. Okay, it's not too much to talk about there. Now, the next one is a patch panel. So patch panels, I'll show you what they look like, and then I'll tell you what they do. All right, so patch panels, they look something like what we can see in these images here. Where's a good one? Let's go here. Right, so you've got this big block with a lot of different Ethernet ports around it, okay? Now, you might think, why would you want a big port for plugging in all these Ethernets when we have things like switches, right? Surely we can just use a switch. That's what the purpose is for. Well, good question. But I think this is best represented actually visually, right? In this instance, we have our patch panel. This purple box over here is representing our patch panel. These squares are representing our Ethernet ports. I drew this myself. I'm not the most fantastic artist in the world. Please forgive me. And then we've got, we'll call this guy Bob. I'm liking the name Bob lately, right? Bob is currently working at PC 1 over here. All right, we'll call that 1. We'll call this PC 2. But he's been instructed to move over to PC 2. Now, what the patch panel allows him to do is essentially say, all right, look, I want to move into this other office, but I don't want to have to take my computer over there and unplug this Ethernet cord and reroute the whole Ethernet cord, because if I don't reroute it, then I'm going to mess up all this wiring, right? I have to actually rewire the Ethernet to make sure everything's plugged in properly over at the switch over here. Or if I have a patch panel, what I can do is I can actually leave all these cables in place, right? These long cables that are pretty difficult to rewire if I'm moving around all the time. And then what I can do is on the other side, right? So this Ethernet cable over here maybe, let's say this one is mapped to this plug on the other side. Now all I have to do is I can move over here, and plug straight into this end of this Ethernet cable, And then all I'll have to do on the other end, well, where the short end of the Ethernet cable is, right, a separate Ethernet cable mapping to that port, I'll just have to say, oh, actually, okay, this one, I'm just going to change this cord, which will be a quick little unplug and replug in and just relabel it, right? I can do that really quickly and easily on the short Ethernet wires that attached from the patch panel to the switch. It allows me to easily move around without having to rewire these long wires every time I want to make a move. Long story short, patch panels allow for Ethernet cable organization, and they stop you from having to rewire your Ethernet cables all the time. All right. So on one side, you've got your long Ethernet cables that plug into this end of the patch panel. This end never changes. It never changes. You don't change it. The only end that changes is the other end, which is over here. This end you can plug in, plug out, and you change it whenever you move, because that's really, really easy. You don't have to rewire anything, right? It saves you from having to rewire everything, is essentially the principle behind it. So patch panels are good for that cable organization and saving you from having to rewire everything. So here we go. Patch panels, cable organization. They keep a large number of cables neatly organized, preventing tangles and making it easier to identify and manage connections. That's pretty much it, guys. You know, that's the general concept behind it. I think I've pretty much outlined it pretty well. That's largely what you need to know. You just need to know patch panels are good for cable organization, know what they do, know when you'd use them, why you'd use them, and you're pretty much sweet. All right. So the next thing we need to know about is a firewall. This is pretty intuitive. Most people know what a firewall is, right? We've all seen, again, little Google image search. We've all seen these images. We roughly probably have had some experience with a firewall before. This one here from Wikimedia Commons on Google image search outlines it pretty well. You've got your wide area network out here, right? There could be some good stuff. There could be some bad stuff. Your firewall makes a decision on what can get in and what can't get in, right? So maybe you say, you know what? As a firewall, I'm going to allow HTTPS traffic on port 443 to come in, because that is secure, but I'm not going to allow HTTP, which is insecure web traffic, on port 80. So I'm going to actually send that back, and I'm not going to let it in, right? So you can decide with a firewall what you let in and what you don't let in. So let's have a look at some specifics. You can do traffic filtering by port number. Remember, we talked about those ports and those protocols. So firewalls can filter network traffic by port number, allowing or blocking specific types of traffic. For example, you can disable HTTP traffic on port 80 to ensure only encrypted internet traffic is allowed, or you can block SSH on port 22 to prevent remote access to your network, right? So you can actually block certain ports in order to disable certain protocols. So if you didn't want anyone in your network using insecure web browsing, if you wanted to make sure they only use secure web browsing, you could block port 80 to ensure that no one could use HTTP. You would only leave open port 443 so that you knew they were using secure web browsing. That's pretty much what that means, right? It also offers traffic encryption, so firewalls can encrypt traffic entering and leaving the network as well, enhancing data security and protecting sensitive information from interception. They can work as a proxy. Remember, we talked about a proxy server in one of the prior exam objectives. Some, not all, but some firewalls can act as a proxy server. We talked about what that is. I'm not going to go into detail again because we talked about it before, so you can go have a look at that. And they can also do intrusion detection and prevention. They can identify that threats have occurred and even prevent those threats from continuing to make their way into your network, depending on how your firewall is configured and what kind of firewall you have. Basically, so long as you understand what I just said there, you'll be sweet for your exam, okay? This is a very broad exam. You don't need to know a lot of depth. That should be plenty for your A+, 100%. The next thing we need to know about is power over Ethernet. So you may have a device like a security camera, which is generally placed up high on a wall somewhere, right? And usually these things are going to be connected through an Ethernet cable because they need to be connected to your network in some way in order for you to actually be viewing them. But they also need power. So in order to stop them from needing both a power cord and an Ethernet cord, we have power over Ethernet, right? Power over Ethernet. It's pretty much in the name. The Ethernet cable would be delivering both power and an internet connection at the same time. And there's two ways that you can do this, right? One way is if you have a normal switch, a switch that is not capable of giving power over Ethernet, a switch that is not capable of injecting power into your Ethernet cable, what you could do in that case, you could get something called an injector. Okay, if you have an injector, what you would basically do is you would take your Ethernet cable, you would plug one end into your injector, you'd plug another Ethernet cable into the other injector, and then in the middle there, it would be injecting power into that cable. Alternatively, you can get a power over Ethernet switch, which is a network switch that supports power over Ethernet, which would essentially put that power into the Ethernet cable directly. All right. So those are your two ways of getting power over Ethernet. You just need to understand the idea that power over Ethernet describes that principle of putting power through the Ethernet cable so that you can power devices such as security cameras, things to that effect. And you can do it either through a power over Ethernet enabled switch or through an injector. That's what you need to know. Okay. Now we're going to get into the standards. All I can say, guys, is pause and take a look. I would be very surprised if you were asked like to identify a specific power over Ethernet standard. You very well may be. I would be surprised, okay? I put the table here just to make sure, but I would be very, very surprised. So, look, I would make this a low priority to study for your exam. Like, leave it till last. If you've got time left, you're good with your 802.11 standards. You're good with your Ethernet standards, right? Your Cat 5, Cat 6, and the speeds of all those. Then you can come and have a look at this. But definitely your 802.11 and Ethernet standards should take a higher priority over your power over Ethernet standards. You'll probably only get maybe a few questions on this, if any, would be my guess. But it can't hurt to know it. And I officially have to say that you can be asked questions on this to cover my butt. So pause the video, have a look at it. Just know you may be asked questions on this. Okay, that's pretty much it. Now we need to talk about different types of modems for different types of internet connections. Long story short, guys, there's 3 different devices we're going to have a look at in terms of devices that connect your internet. The first one is a cable modem. Whenever you see the word cable, just know that's talking about, it relates to the television network. Okay, so a cable modem is using previously existing television structures, television wiring to provide an internet connection. And a cable modem is what translates that television connection into a usable internet connection. That's largely what you need to know, right? You can pause and read to look at the data signal conversion and all of this stuff here. But what you need to know is that the cable modem is television-based internet connection, and the cable modem is what translates between those television signals and allows that to be used as an actual form of internet. All right. You're likely to be given a question along the lines of like, a person is living in an apartment and uses previously existing television infrastructure to access an internet connection. What type of networking hardware are they using? Cable, DSL, optical network terminal, or whatever else. And just because they've used television infrastructure, you'll be able to know it's cable, right? So really, that's what you need to know. Pause and read those notes if you want, but I think that's plenty for you, to be honest. DSL, same thing as cable, but instead of television network, it is previously existing phone infrastructure. All right, so the DSL modem converts that previously existing phone infrastructure into a usable internet connection. If you see DSL, you know that they're talking about telephone lines. All right, telephone lines. That's pretty much it. Again, guys, pause and have a read, but just know DSL modems are converting those previously existing telephone infrastructure into usable internet connection. That's a DSL modem. That's pretty much it. And finally, an Optical Network Terminal, or ONT. Now, what this is talking about is your fiber internet connection, all right? So you would have a device on your house that you would plug your fiber. So, you've got your house over here, happy family in a happy house, blah, blah, blah. And then on the side, you might have a little box where your fiber network cable would come in and plug, and then your usable internet connection would come out the other side on the inside of your house. And that is an ONT. It's converting that fiber into an internet connection you can use on the inside. Same concept as the other two. So in this case, for your exam, if you were to see person is using a fiber connection, which of the following devices are they most likely to have? Cable modem, DSL modem, optical network terminal. It would be the optical network terminal because that's the one that is responsible for turning fiber into a usable internet connection on the inside of a house, right? It converts that signal. So that's pretty much it, guys. You just need to be able to differentiate between cable, DSL, and optical network terminal in terms of what kind of internet is associated with them. That's largely it, okay? So the key distinctions here, you've got your cable, DSL, optical network terminal, talks about the speed and the cost. So as we should know by now, fiber is the fastest. Cable is generally going to be faster than DSL. But then you also got to think about the cost. So fiber is also the most expensive. Cable is a good in-between option, and DSL is generally a little bit cheaper. All right. Just know that cable uses television cables, DSL uses pre-existing phone lines, and optical network terminals is talking about fiber optic cable connections. And you should be sweet for your exam, guys. Finally, our network interface card. We have talked a little bit about the network interface card. We should know plenty about it. There's a lot here you can pause and read. You just need to know that on the inside of your machine, there is a network interface card, and that is what is responsible for allowing you to access either a wired or wireless internet connection. You can get a wired network interface card where you need to use a Ethernet connection, or you can get a wireless internet connection, a wireless network interface card where you would be able to access a wireless internet connection. That's pretty much it. Long story short, there's really not much more for me to say on that. That's a pretty good summary, right? Other than we should know by now that the network interface card is what actually has your unique MAC address. We have talked about MAC addresses in a previous exam objective, so we should be familiar with what a MAC address is. If you're not, maybe go back and have a look. But the network interface card is what provides you with your MAC address. All right, we should hopefully know that at the moment. So pause and read that if you want, but I'm going to move on because we can move on. That's pretty much what we need to know. Now, what is your MAC address, and specifically what does it look like? We know, or we should know already, that a MAC address is a unique identifier that specifically identifies your physical device. It's not an IP address, it is a MAC address. The only device that has your MAC address is your device, and that MAC address comes from your network interface card. So it is called a media access control address, or a MAC address. It looks something like this. Okay, you may need to visually identify it. You'll just need to know that that it looks different to an IPv4 address, an IPv6 address, and a URL on a website, right? You need to be able to have a look at maybe an IPv4, IPv6 MAC address and URL address and say, oh yeah, that one's the MAC address, right? So they're all pretty distinct. They all look quite different. Yeah, the MAC address, right, it's in pairs separated by a colon there. All right, so that's the dead giveaway. In pairs separated by a colon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in total. All right, it's a 48-bit address. Right, so just be able to visually identify it, know that the network interface card is what gives you your MAC address, and it is a unique physical identifier for your device that comes from your network interface card. All right. So when your network interface card receives a data packet, it checks the destination MAC address in the packet's header. If the destination MAC address matches its own, the NIC processes the packet and passes the data to the device. If the MAC address does not match, the network interface card ignores the packet, right? So if things are being directed using a MAC address, your network interface card will be able to say, yes, that's for me, or no, that's not for me. All right. That's pretty much what we need to know. Now, guys, we're going to get into some questions, some multiple choice questions. Have a look. Can we identify the network hardware that is being discussed in the question? I'm going to try to fly through this as fast as I can. Question number 1. A network engineer is tasked with managing the extensive cabling system in a large data center. Instead of running long cables directly from each server to the switches, the engineer opts to use a device that gathers all the cables into one centralized location. This device not only helps keep the cables organized and labeled, but also allows for easy changes to the cabling configuration without having to rerun wires every time a connection is modified. Which device is being described? A router, B, a switch, C, an access point, or D, a patch panel? Pause the video if you need more time. I'm going to go ahead and give you your answer in 3, 2, 1. Hopefully we got it. It is a patch panel. That's right, guys. Remember, a patch panel is what is responsible for those that cable organization. You plug one end into the patch panel and the other one goes into the switch so that you don't have to rerun those cables, as we talked about in this very video that you're watching right now. Pause and read the rest of that if you need more information. If you got it wrong and you want to read what the others were, if you missed it. Otherwise, we're going to keep it moving, keep it kicking on with the next question, which reads, a growing company needs to connect numerous devices across different departments while also segregating network traffic for enhanced security and performance. The IT team plans to use VLANs to logically separate the network into distinct groups such as sales, marketing, and HR. They also require capabilities like SNMP monitoring, port mirroring for troubleshooting, and traffic prioritization to ensure critical applications have sufficient bandwidth. Which device best meets these requirements? A. Managed switch. B. Hub. C. Unmanaged switch. D. Smart manager. Pause the video if you need more time. Come into your answer in 3, 2, 1. That was a managed switch was the answer for that one. So guys, remember, a managed switch is the one that allows you to have all of those complex capabilities, do VLANs, use simple network management protocol, all that stuff. We talked about that in this video. I'm not going to hop on about it. Pause if you want to read all this. I'm going to be moving on though, guys, to the next question, which reads, a university is upgrading its campus network to support modern devices such as IP cameras, VoIP phones, and wireless access points. To simplify installation and reduce cable clutter, the IT department intends to use a device that delivers both power and data over the same Ethernet cable, eliminating the need for separate power cables and outlets. Which device best meets these requirements? A. PoE injector. B. Router. C. PoE switch. D. Powered Cat5 cable. Pause the video if you need more time. Your answer coming in 3, 2, 1. Here we go. It is C. Power over Ethernet switch. Now, this was a tricky one, guys, because we had power over Ethernet switch as a potential answer, and we had power over Ethernet injector. The key here would have been in reading the question carefully. So the question actually says, if we go back and have a look at it, it says it's upgrading its campus network environment. So if it's a campus network, if you were to use an injector, you would have to place an injector on every single Ethernet cable. A campus is a pretty big area, guys. That's going to be pretty expensive. This is one of those times where it's best to just invest in the power over Ethernet switch, because you buy one switch and you can power multiple different Ethernet cables, right? Otherwise, you'd have to purchase multiple different injectors all over the place for all your different. It's too much. On this scale, you would want a power over Ethernet switch in this situation, just because of the scale, and also they didn't say that they were trying to save as much money as possible. They were just trying to to simplify installation and reduce cable clutter, right? So the power over Ethernet switch is simply the best option for that. So pause and have a read of the answer and description there if you want, but I'm going to move on to the next one, which reads, Alex is experiencing intermittent connectivity issues on his desktop computer, which is connected via an Ethernet cable in his office. The IT department informs him that the component responsible for this connection is either built into the motherboard or installed as an expansion card. This device converts the digital data from his computer into electrical signals for transmission over the network, and conversely converts incoming electrical signals back into digital data. Moreover, it identifies the machine on the network using a unique 48-bit MAC address, ensuring that packets are correctly delivered only to it. Which hardware component is being described in this scenario? A. Cable modem. B. NIC. C. SPF, or D. Routing table. Pause the video if you need more time. Your answer coming up straight away in 3, 2, 1. It is a NIC is your answer. All right, NIC. Remember, guys, your network interface card is what gives you your MAC address. Your MAC address is tied to your network interface card, right? That's really crucial to know. Cable modem gives you an internet connection over previously existing television infrastructure. SPF is the sender policy framework. We talked about that in the email authentication, in the text records of the DNS in a previous exam objective. And a routing table is just something that a router uses to see where should I send this packet based on the IP address that it's meant to be sent to, and my understanding of the current IP addresses that I know. So pause the video, read that if you didn't get it, if you want more information there, but we went over it in this video, all right? So with that being said, if you want a free practice exam, guys, it's got performance-based questions in it, it's got multiple choice questions in it, 90 multiple choice questions. You can head over to the link in my description or in the pinned comment and grab that. Alternatively, if you want to get your A+, guys, huge news right now, right? I used to have my learning guide for $55 and the ultimate learning guide for 80 Australian dollars. I've scrapped this and I've just put everything into the $55 package, all right? So with this, first things first, this is helping people pass their exams. That was my previous version, whereas this one's way better. So in this package, you get all of this. You get detailed notes, multiple choice questions, performance-based questions, everything you could ever need broken down by exam objectives so that you can actually track your objectives, your progress, and you actually get 11 performance-based questions at the very end as well. Okay, so you get notes, active recall questions, active recall answers, multiple choice questions, detailed explanations, and 11 performance-based questions. And you can see the detail that it's broken down into. You get the exam objective, and then it's also broken down into every separate dot point. So you know for a fact you're not missing a thing. It exactly aligns with the exam objectives that CompTIA gives out. All right, so you've got your multiple choice questions, your detailed answers, your performance-based questions as well. And you also get some bonus stuff. You also, would you believe, you also get a video on how to 10 times your learning with free AI tools, where I show you 2 really cool AI tools that you can use to learn your weak areas way faster. And you also get a video where I show you exactly how to use multiple choice questions to study and what you want to be doing. All right, look at me, I got a little face. I'm waiting for you. I'm waiting for you inside the course. Look at me there, waiting for you. All right, so if you want that, you can go and grab it. It's over at journeytocyber.com. Links to all this stuff, the free exam and the learning guide, is in the description and in the pinned comment. That being said, I'll see you in the next one, guys. Catch up. Good luck. You're going to absolutely 100% pass this thing. See you later.